Okay, we're going to do page 1 and 2 of differentiation. If you remember in the investigation, we found the derivative, or we differentiated the y equals x squared function, and we got y equals 2x. Now, we did it graphically, but as you can see from this rule, the way you find the derivative using analytical rules is you take the exponent and you put it in front. So you take the exponent, you put it in front, and then you reduce the exponent by 1. So like, for example, if you have x squared, the 2 comes out front, and then you replace it with exponent minus 1 on top, which is just 1. So, and then the way you write the derivative is with the prime. So you write y prime. Now, the other way you can write a derivative is dy dx, and then you can you can bring the 3 down front, and then you're left with 1 less in the exponent. Okay? So those are the two examples that we did in the investigation. So all of these, you do it similarly. Okay? And the reason why there's two different notations for the derivative, this and this, is because you might have read in your book that calculus was invented pretty much at the same time by Newton in England and Leibniz in Germany. And because they kind of invented at the same time, each one had their own notation. And sometimes it's convenient to use one of the notations, and sometimes it's convenient to use the other. So you will see both. Okay. Let's see. So these examples here are just showing you different examples of the rules. And one thing you see in the examples that we did not do in the investigation is, if you already have a coefficient in front, like y equals 2x cubed, the 2 remains out front. So when you bring the 3 down, you just have 2 times 3x squared, and then you can multiply these together to get an answer of 6x squared. Okay? So let's do just the odds here. We'll do A, C, E, I, G, K. So the first one, instead of y equals 4x squared, we're going to find the derivative. So it's y prime equals 4 times 2x, because remember the derivative of x squared is 2x. And then we end up with y prime equals 8x. Okay, so that's A. C would be y equals 7x to the fourth, and notice they're using this notation. So normally when they ask you for that notation, you would continue to use their notation. So we'll use dy dx equals 7 times 4x cubed, which is the same thing as 28x cubed, right? And then let's see, E, we have y equals x to the fourth. When we take the derivative or differentiate that, we are going to bring the exponent out front, 4x, and then we're left with cubed in the exponent, 4x cubed. What about G? So G is y equals x, and this is kind of a tricky one. Y equals x is actually y equals x to the first. So if we use the rule of taking the derivative and reducing the exponent, putting the exponent out front, we're going to get 1 times x to the 0, right? And actually that x to the 0 is 1, so that just equals 1. Okay, so the derivative of x is just 1. That should make sense because y equals x is a line, and the slope of the line is 1. And remember, when you take the derivative, it just gives you the gradient, or the slope. I. So y equals 9x squared, dy dx would be 9 times 2x, which is 18x. And then k, last one, y equals 1/2 x squared, dy dx is equal to 1/2 times 2x. If we multiply this out, the 1/2 and the 2 cancel, you just end up with x here. Okay? Moving on. Okay, so now we're still just going to do the odds here. differentiate. So let's see, if we differentiate y equals 7, y equals 7 is the same as y equals 7 x to the 0, because x to the 0 is 1, right? So if I use the rule, the power rule, and I bring the 0 out front, I'm just going to get 0, because everything gets multiplied times the 0 and it disappears. Okay, so the derivative of a constant is always going to be 0. And that should make sense, because if you graph this line, it's a horizontal line. The gradient of a horizontal line is 0, so that makes sense that the derivative is 0. Right? Okay, C. Here you have y equals negative 1/4 x to the 4th. When you take the derivative, by the way, that I should put a prime there, it's equal to negative 1/4 4x cubed. The 4's cancel out, and we get negative x cubed. Okay, and E, y equals negative x. So if we take the derivative of this, we're going to get y equals negative 1. Okay, because this is y equals negative x to the first. We're going to end up with negative 1 times x to the 0, which is 1, negative 1. Okay, and that should make sense, because y equals negative x is a straight line with the slope negative 1. Well, the derivative then is going to be the function negative 1. G, y equals 5x to the 6th. It's going to be 5 times 6x to the 5th, which is 30x to the 5th. I, y equals 1/2 x to the 8th. Y prime would be equal to 1/2 8x to the 7th, which is equal to 4x to the 7th, because these multiply together. And last of all, we have y equals negative 2/3 x to the 9th. We're going to put y prime equals negative 2/3 9x to the 8th. And these kind of cancel out. You're left with 3. You get negative 6x to the 8th. Okay. Next page, because we are doing 1 and 2 together in one period. Okay. Here they're just saying that, hey, if you have a function with a bunch of terms added together, all you do is operate on each term separately, and then you just add up the result. So, for example, the derivative of 3x is 3. The derivative of negative 4x squared is negative 8x, and the derivative of x cubed is 3x squared. You just add them all together, just like they were added up together in the original function. Okay. So here we're just going to do A and C. So here, you start out with f of x in the notation, and then when you take the derivative, you just do the prime there, just like we did with the y. Let's see, the derivative would be 3 times 2x plus 5 times 3x squared. So that would be equal to 6x plus 15x squared. That was A. C. The derivative of that would be 9 minus 11 times 3x squared. The x disappears because the derivative of y equals 9x is just 9. 9 minus 33x squared. The reason why the derivative of y equals 9x is just 9 is because, remember, y equals 9x is 9x to the first. You multiply the 1 out front, and then you're left with 0 up here. X to the 0 is 1, so it's just all equal to 9. Okay? All right. Next. Find y prime, or the derivative of each of these. So we're just doing A and C. So the derivative of the first one, A, is y prime equals, and the derivative of any constant in 8 is 0. The derivative of an x term is just the coefficient of the x term. And then the last one, which, ironically is maybe the easiest one to do, is just like that. Okay? So you're equal to negative 5 plus 24x to the 5th. And then C, you're going to do y prime equals, and then derivative of 7x is 7. The derivative of 4x to the fifth is 5 times x to the fourth. And the derivative of constant negative 101 is 0 because derivative of a constant is 0. So we have 7 plus 20x to the fourth. Okay, and this just says, hey, you can write y prime instead of writing dy dx. And that's it for the first period.